What can we do? You were quizzed on this yesterday or the day before. What can we do? What's the only... Is there any algebra? Is there any factoring we can do? What? Multiply or divide by a form of 1. So let's actually multiply by a form of 1. What do you want to multiply by, Lily? Well, the square root of x squared plus x plus 1. What? Plus the square root of x squared minus x over what? The same thing. You better do the same thing or you're going to change the value of the limit. Now, there's nothing on the denominator, but you end up on the numerator, x goes to infinity of x squared plus x plus 1 because square root times itself. And then the middle term cancels out, and you're left with this. The middle term cancels, and you're left with this, x squared plus x plus 1 plus the square root of x squared minus x. What happens on top? What cancels? The x squareds cancel? No, that doesn't cancel. No, it doesn't cancel. It's just 2x, right? Thank you. Thank you. Don't let me make stupid mistakes. The limit as x goes to infinity of what? 2x plus 1 over the square root of x squared plus x plus 1 plus the square root of x squared minus x. You have to be very careful at this point because you can't just plug in infinity now. You can't just plug it in. You have to be very, very, very careful. What do I do at this point? You multiply or divide by a form of 1. What are we going to divide by now? We did this once before. We're going to divide by what? Do you remember we did something like this? Do you remember this when we were proving one of the limits? You have to be very careful. When you have square roots on radicals, you have to be very careful. If you do this, what is the square root of x squared? So you are effectively doing this. The limit as x goes to infinity of 2 over, I'll do this whole thing out, plus 1 over the square root of x. And then this thing right here is squared plus x plus 1 over the square root of x squared plus the square root of x squared minus x over the square root of, and this is squared, right? And there's an x right here. So what does the numerator become? What does it simplify to? 2 plus 1 over x. And what does the denominator come out to be? The square root of 1 plus 1 over x plus 1 over x squared plus the square root of what? 1 minus 1 over x. Exactly. Now when you go to infinity, what does this go to? 0. This goes to 0, 0. So what does this come out to be? 2 over 2, which is 1. So we just proved as it goes to infinity, it equals what? 1. Absolutely. Absolutely. So the question, though, is this is where it gets really tricky. If this is a continuous function, the domain is all real numbers. Where is this continuous? Yeah, all real numbers. That means all real numbers. Another way to say this is, you can just say this. That means all real numbers, that are with the double bars. If the domain of all the pieces is all real numbers and you put it together in such a way that doesn't, like no divide by 0, no even roots of a negative number, you're all set. This is still the problem. We still have this r minus 9. In order to plug in 9 into this equation, we need to somehow cancel out that r minus 9. Any other thoughts? My strong suspicion is exactly what you just said, which is you know what you probably need to do. Well, the problem is this. If you multiply that all out, you need to be able to cancel out this r minus 9. You need to be able to cancel that. Are you going to have to? What do you think? Let's see here. Again, I would look this up, but I can't. If you multiply this out, you end up with r over the square root of r times, let's square it. It's r squared minus 18r plus 81 times r squared minus 18r plus 81, right? Yeah, it's nice. It's a good time. What do we think? Do we have to? Do we have to?